Hello everyone, let's do some calculus in Rust. Rust has got a crate called Peroxide, which we're going to use. I've just done cargo add Peroxide in my main. So let's start with use Peroxide. And it's going to take a while before I get the hits. So there we go. I think I want Prelude. Start. And this is the example we will do. If you've done integrals before, you're given a function, and what you do is you add 1 to each of the indices, and then you divide number before the x by that number. So n plus 1, and then that number is over n number. It's easier to actually do with numbers. So 3x squared goes to 3x cubed, and then you take the 3 of the new power, and you move that underneath. So 3 over 3, and that just takes you back to 3 over 3 is 1. So that's what gives you x rather than 3x. The 2x here, that 1 goes up to 2 because you're adding 1 to it. So it's 2x squared, but you also take that 2 down below, so it's 2 over 2. So that cancels that very conveniently. And then the 5, that just goes to, from number 5, it goes to 5x. Because you're basically multiplying everything by x. You're multiplying this bit by x, that bit by x, and that bit by x. And so the original graph, the blue line, is 3x squared plus 2x plus 5. And with an integral, we want to calculate the area under the graph. We're going to be calculating between x equals 5 and x equals 10. This is the maths of it all. So 10 cubed is 1,000. 10 squared is 100, plus 5 times x, which is 50. The lower one is 5 cubed, plus 5 squared, plus 5 times 5. And you subtract that one from that one. So 1150 minus 175 gives you 975. So the area in red hashed there is 975. So let's see if we can actually show that or do that calculation, but in Rust, such that we can potentially one day automate this type of thing. I actually, let's just say, I actually got Claude to do this, but I'm going to ask ChatGPT. Show me the calculation code in Rust using Peroxide, integrate function. It should just be a 2 or 3 liner. Yeah, so we've got the integrate function there. And the integrate function takes f, where f is a closure. So whatever your actual function of your curve is, right out here, right out. The integrate actually does what I've just showed you in Excalidraw. So integrate takes this and converts it. And converts it to this. So Peroxide is doing that, which is nice. So import everything from Peroxide. Don't ask me what that FUGA is. I really don't know. So let's I'm just gonna copy and paste that because just turn off type hints as well, just to make it slightly less scary. So we've got a closure where x is an f64. We're doing 3 times x to the power of 2, so 3x squared plus 2 times x plus 5, which 3x squared plus 2x plus 5. So that's our blue line. To work out the area underneath it, this is where you need the integral. So this is where you increase the indice, and then you take that number and divide the bit at the front. I can't remember. I can't remember. Got the exponent, the mantissa, radix, yeah, whatever. Right, so this is your closure. Closure of the function of the blue line. Okay. And to be honest, you just then do the integrate function. So let res equal integrate. Yeah. Then you pass in f, which is your function, which you've already got. And then you do got a tuple of, what am I doing it between 5 point, you have to do this as an F64, 5.0 and 10.0. Check that on the ends. We want, the result should be 975. This might take a while because I think it's about 250 crates. Not correct. Well, yeah. When you add peroxide, there we go. Oh, because it's float, we could fix that. Dot 2F, is that right? I've forgotten how to format. That's bad, isn't it? It's I can't remember. Format. Been doing too much AI. Decimal places. It's late. It's nearly midnight. I shouldn't be doing this, but I just wanted to do it while it was. Yeah, there it is. I have that right the first time? What's going on? Then 2. Oh, I think I had my Python head on. Yeah, 975. 2 decimal places. So for all that complication and all that studying when you're younger, you can just do it with integrate, which is amazing. Obviously a lot more to it than that. The next thing to do would be to work out the area the area. If you had, you could have another parabola. You could have one that goes like that. And then you could work out the area between there and there, such that you work out this area. That starts getting a bit more difficult, but what you do is you have function for this, and then you have another function like that, but for this one. And then you subtract one from the other. But you can get into a muddle with positive and negative. So that's your 975, which is what we had here. So it really is that simple, right? But you just need to be it helps if you understand the theory, or at least Some of the theory. If you're more interested in actually learning about how it works, the way you can approximate it, the way it's taught, is that you have all these little strips, very thin sort of slices. All these slices, very, very thin, is each one. You add them all together, and that then gives you the area. But they are called infinitesimally small. So as they go towards zero, that's when you get the most accuracy, which is what you want. So these strips are really just a way of validating this, which is what Isaac Newton discovered in the 1600s. So yeah, we've been standing on the shoulders of giants for what, 400 years. So you start off with a formula, which is all very well, but where do you get this formula from? So where do I get the formula from if it's my own data? This is interesting. So if you've got your own data points, you actually need to do interpolation. So that's not the answer I was expecting. Linear regression, yeah, so what you basically keep iterating over the line until you get a function that very closely would produce the line that you see. So linear regression would give you a straight line, and then you can do stuff with quadratic equations, which can approximate your parabola if that's what you've got. And then you also get exponentials with I remember this from the Tim Click's Rust in Action book. So explain mantissa, exponents, and radix. So radix is the base of the number system. Mantissa is the fractional part that contains the significant digits. Then you've got the exponent. The exponent is sometimes that'll be called is it called the index sometimes? So the mantissa there is 5.67. Radix is 10. The exponent is 4. So that's you're saying something is to the power of 4. That's the exponent. MRE. You can remember it if you remember it as MRE as like a meal ready to eat. M R. But that's kind of like scientific notation, which is not exactly what we were talking about. So I've slightly gone off on a tangent, but this is a formula rather than actual representation of a number, because that's what the mantissa radix exponent is. It's a representation of a number, whereas what we've got here is a function. Then we convert the function into compute the definite integral. Oh, look, they're doing the subdivisions. Why do the subdivisions? Is that necessary? Let's just put that in. So that's utterly accurate. Why would you even want to put in subdivisions? I don't know. It's not even looking like it's an option there. No. I would ignore that. AI can lead you up the garden path sometimes, so. You can almost remember this. I think I'll be able to remember this tomorrow morning. So you just have a closure where you pass it X and then the POW as power in the I is integer because you're passing in 2. If you weren't using I, would it still work? No, what's the error? Expected F64. So just for ease of reading, probably typically want quit. You typically want to be using a power just of 2 there rather than 2.0. I could put in 2.0 there. That'll work. But if you put in I, it tells it, isn't it? It tells it to use an integer, so that's kind of just a bit neater. Yeah, so Peroxide, worth checking out. It's quite a big library. I've just used integrate. There are many other functions that get with it. When you install it, you can see. So if we do, yeah, all this 03, you can use Python. Cool. So that is a quick look at doing calculus with Rust. You can do it with Python, obviously, Jupyter Notebook, Pandas, NumPy, and all that good stuff. So I just thought I'd show how you can do it in Rust with 3 lines of code. Helps if you know all this or if you've done it at school, but if you want to work out the area under a graph, which is something you may actually want to do in real life, let's just explain why you might need to calculate the area under a graph in the real world. It'll be speed, distance from speed, revenue, economics, revenue or cost. Graph of price over time. The area is the total money spent or earned. Drug dosage. Energy use. That's it's going to be a popular one these days, isn't it? You could apply that to Bitcoin mining or AI data center. That would be quite a real world use case. Probability and statistics, environmental science. Oh yeah, flow rate from a river over time. So quite a few of these are with respect to time, where time is typically the x-axis. Engineering and machine learning. There we go. The area under ROC curve in classification models measures model performance. Well, that's something to go away and research. AUC, area under ROC curve. In classification models, it measures model performance. So thanks for watching. That's a quick intro to doing integrals for calculating the area under a graph that would represent some of these things that we just looked at. The other one would be gradient at any point. So if you're working with differentiation, say you want to work out what the actual gradient is at that very point, that's when you use derivative. That very point, that line will have a exact gradient at that one point. So we'll cover that another time, but hopefully this has just given you an introduction to using Peroxide with Rust for doing calculus. So yeah, off to the races. Happy days. Thanks for watching.